In this video, I'm going over solving our radical equations. So here, just keeping in mind, we have focused on like the radical, like the square root, but we would always have starting with solving our quadratics, like let's say x, sorry about that, hold on one second, x squared, let's use this, x squared minus 6 is equal to 4. So we've been solving these types of equations, right? Where we would add 6 to both sides and x squared is equal to 10. Then what is the inverse, or what would we do last year to get rid of our exponent? We would take the square root. So then here now we are left with, now taking the square root of a value here, we're left with the positive and negative radical 10. So keep in mind, we're solving equations and we're using the inverse operation. We're just now going backwards and we're starting with the radical. So keeping that in mind. So same thing here, right? We would get the radical by itself. So if we're subtracting 6 on the outside of it, I'm going to add 6 here now to both sides. Bring down radical x is now equal to 10. Now, we're not going to take the square root because this is the square root. So now what is the inverse of this radical? Well, keep in mind, it has that understood index of 2. So we're going to now square both sides. So now here we are left with x is equal to, since we're asking what number would only give us a positive 10 here, so then that means we would only have positive 100. So keep that in mind here when we start talking about raising to that second power, even to an even power. So then now here, notice a little different. Now we're still subtracting 6 on the outside, so we would add 6 on the outside. And now I've got the cubed root of x is equal to 10. Now see how here this is a cubed root. So I'm not going to raise to the second power. That's for the square root. So what do you think would be the inverse here? What are we going to raise to what power? The third. So that is using the index here. That's your inverse. So now x is equal to 10 to the third power, which is 1,000. So the square root, or cubed root, sorry, of 1,000 is going to give you 10. Now, we're talking about this because let's say we have this equation, and we'll go through and solve this one. So what would we do first? Well, we would subtract the 6. And so now here I've got square root of x is equal to negative 2. Now, is there the square root of a number that would give us negative 2? Well, no, because if you were to try the square root of negative 4, you're going to get an error message. And we're going to talk about this next semester, how you end up with an imaginary number for this. So the square root of negative 4 is not going to give you negative 2. So if I were to try and solve this, then we're going to end up with, we could, so you'll see here, let's say I just go through and solve, right? And I've got x is, let's say we're going to say equal to 4. Well, let's plug it back in, right? Because just to show you why it's positive 4, negative 2 to the second power, negative times a negative is a positive. Let's plug it back in so you can see. The square root of 4 plus 6, right? We're saying that by plugging this in, that we should get equal to 4. The square root of 4 is 2. Well, what's 2 plus 6? 8. Is 8 equal to 4? No. So notice how is 4 a solution? No. So notice how here we have this x is equal to 4, which is what we're going to call and reference our extraneous solution. So again, going back here, whenever we have the square root equal to a negative value, we cannot take the square root of a negative and equal to a negative value, and we're going to be left with an extraneous solution. So just to show you what this looks like, graphing in Desmos. So you can also show and graph in Desmos. You're going to graph each of these as if their own separate equation. So you're going to graph the left side, radical x plus 6. Now you can't just put 4, so when you graph this, you're going to have to put y is equal to 4. So it looks something like this here. So you're going to graph radical x plus 6, and it looks like this. You would graph y is equal to 4, and it shows a straight line. So notice the graph. The solution is going to be where they cross each other. Well, do they cross each other? No. That's why this is considered an extraneous solution. And that means because these never cross each other, these graphs, we have no solution. So now that's why I wanted to go over this, because we're going to have to keep in mind with radical equations, we could have an extraneous solution. So here, with the cubed root, I'm going to subtract 6, right? Got adding 6 on the outside. But now the cubed root of x is equal to negative 2. Now, we can take the cubed root of a value and it will get us negative 2. If you put the cubed root of negative 8, put that in your calculator, right? Cubed root of negative 8, you will get the solution of negative 2. So now, even though we have the cubed root to a negative, we will have a solution. So if I raise both sides to the third power, they cancel out, and you're left with x is equal to negative 8. Plug it in, you do get negative 2. So notice how here we can have a cubed root equal to a negative value. You will get a solution. So keep in mind, if the index is odd, 3, 5, 7, you can have a negative solution. But if it's even, like square root, you cannot have a solution. Then notice here, if we were to graph them, right? Because remember, you graph the left side and you put y is equal to 4. Notice how here, and I can try and make this bigger so you can see. When you graph this in Desmos and it looks like this here, they cross here at what value? X is equal to negative 8. So it's counting by twos, negative 2, negative 4, negative 6, negative 8. So again, keep in mind this idea of an extraneous solution, and we're going to have to check. If we have a radical raised or equal to a negative value, this is extraneous, no solution. But if it's a cubed root and or an odd, then equal to a negative, we will have a solution still. So now here we go. Notice how we are still going to solve. See how everything is inside of our cubed root? There's nothing outside of it. So we can go ahead and get rid of the radical here. It's a cubed root, so we're going to raise both sides to the third power. So here we go. Now I've got 3x plus 1 is equal to 2 to the third power, which is 8. Now notice we're just solving a two-step. Subtract 1, right? Opposite operation. 3x is now equal to 7. And now last step, divide by 3. And x is equal to 7 thirds. So here, go ahead and try the U-try on your own. Now before we do, notice how we have a radical and it's equal to a positive. So we're good. We're going to have a solution, nothing extraneous. And here we go. So same thing. We had the radical, everything inside. So now raise both sides, but not to the third power, right? To the second power. So this radical cancels out. Bring down what's inside. X plus 12 is equal to 1. Now here, all you had to do to solve for x, you were adding 12 to it. Subtract 12. And x is equal to negative 11. So now in number 2 here, our second example. Now notice our radical is not by itself. We have this minus 5 here outside of it, so we do need to get rid of this. So we need to add 5 first, right? Opposite operation. Add 5 to both sides. So now 10 is equal to radical x over 9. So now see how the radical here is by itself? Everything is inside. So now we can solve. Notice how our square root is equal to a positive, so we're good. We'll raise both sides to the second power here. So 10 squared is 100 and x over 9. So now here we're solving for x, but it's being divided by 9, so don't divide by 9, right? We need to multiply both sides by 9. And so here you get x is equal to 900. So go ahead and pause the video now and try the U-try on your own. And here we go. So you should have noticed that this cubed root was not by itself, right? What's outside of it? The plus 5. So to get rid of it, we need to subtract 5 from both sides. Cubed root of x plus 20 is now equal to 4. So now here, what do we need to do to solve? Not raise to the second power, right? Raise to the third power to get rid of the cubed root. And x plus 20 is equal to 4 to the third power is 64. Now, to solve for x, you add 20, so we're going to subtract 20 from both sides, and x is equal to 44. So now with our next example here, again, is the radical by itself? No. So notice how here we're multiplying the radical by 3. So what do we need to do first? Divide both sides of the equation by 3. Now here I've got radical x minus 5 is now equal to 6. So now here we go. We have the radical by itself, square root, equal to a positive value. So we're good. We'll have a solution here. So we can go ahead and square both sides to get rid of this radical here. Inverse operation, bring down x minus 5, which is equal to 6 squared, 36. So now here, solving for x, I'm subtracting 5. And so now add 5 to both sides. And x is equal to 41. So go ahead and pause the video and try the U-try on your own. And here we go. So we're solving a cubed root equation, but it's being multiplied by 4. So you were supposed to do what first? Divide by 4. So now here you've got the cubed root of 2x minus 5 is now equal to 3. So now I'm going to raise both sides to the third power here. Now I've got my cubed root. 2x minus 5 is equal to 3 to the third power, which is 27. Now notice you're solving a two-step. So you need to first add 5 to both sides, and 2x is equal to 32. So now last here, divide both sides by 2, and you get x is equal to 16. So now let's go to our last example here. Notice we're solving a cubed root equation. However, we have a couple things outside of it, right? What do you notice? We're multiplying it by 6, and the plus 14 is on the outside. So what do we have to do first? Well, we got to get rid of the and always add or subtract first. We're going to subtract 14 now here from both sides. So 6 times the cubed root of x is equal to 6. Now we're still multiplying the cubed root by 6. So now what do we need to do? Divide by 6. And now I've got the cubed root of x is equal to 1. Now we can get rid of our radical here and raise both sides to the third power. And x is equal to, that's 1 to the third power, which is just 1. So now go ahead and pause the video and try the U-try on your own. And here we go. So notice how here we had multiple things going on here, right? Because only the square root of x is what's inside the radical. So we need to subtract 41st from both sides. So now here you get negative 24 is equal to 8 radical x. Now you're still multiplying the radical by 8, so then you needed to divide, right? Do the inverse operation, divide by 8. Radical x is now equal to negative 3. Now you should have noticed this radical, square root, if for those who rushed and raised both sides to the second power and said x is equal to 9, what's wrong? This radical is equal to a negative 3. Can we take the square root of a value and add it and set it equal, and will you get a negative value? No. So is this going to have a solution? No. So for those who said 9, because you raised this to the second power, this is an extraneous solution. So this equation technically has no solutions because, again, this radical cannot equal a negative value because the square root of 9 will get you 3, not negative 3.